Okay. So we start with talks about Astro Pi and SumPy, so the big packages, and then we go for smaller packages. So our first speaker is Adrian Price-Whelan, who is a postdoc in Princeton, and he's one of the key persons behind Astro Pi.
Thank you. Cool. So my name is Adrian Price-Whelan. I'll do a little bit more of an introduction in a minute, but I wanted to actually start with a plot or a figure. In the past, I think AstroPy overview talks have started with a history of AstroPy, how it got started, and in the times when other programming languages were the dominant and Python was sort of just the underdog. But I want to start with this because I think you could probably guess which line there is Python. So this is mentions in the astronomical literature, just full text searches in ADS. Python is really now the de facto language in the astronomical sciences. So it's taken off, we're in that state, and that's now the context for the rest of the talk. So what is the AstroPy project? I think the AstroPy itself, the collaboration, the community around the AstroPy project is partially responsible for this large upturn for mentions of the Python programming languages. You notice that around 2013 is when the real skyrocketing started to happen. So this is just going to be an overview of the various elements of the AstroPy project, which I think can be split into 3 different topics. So one is the core package, the code that you get when you do pip install or conda install AstroPy. The community surrounding the project, so that's us, we are the community, and many other people who are not able to join. And then the ecosystem of other packages that work with AstroPy or use the package template or use units or whatever, just as a dependency. So that's what I'm going to cover in this talk. I'm going to go a little bit into each of those things. But I thought I would start with just a little of a personal introduction about myself. So I'm an AstroPy user. I'm also a maintainer, so every piece of code that I write basically involves an import AstroPy statement for something, either for units or coordinates or one of the other subpackages. But I'm primarily a scientific researcher. I'm just a postdoc at Princeton. The work that I do mostly focuses on stellar dynamics within the Milky Way. And so as I mentioned before, you may have noticed that something important happened a few days ago, just last week. So things are a little crazy right now, but I do like to write code and think it's very important that we contribute back to open source projects. So for example, here's my GitHub page. I have way too many repositories. I do not recommend getting into that state. I have repositories that duplicate each other in functionality but have different cheeky puns for names that I don't remember. I use Python primarily to do data analysis and statistical modeling, build dynamical models and simulations, to analyze survey data, to visualize data. I don't do a lot of data reduction. I don't do a lot of image analysis, spectroscopy, things like that. So I just wanted to give you the context for myself because we each have our own goals and reasons for using AstroPy and wanting to contribute to AstroPy, and mine is sort of listed here. So within the AstroPy project, these are my roles. So I'm the deputy maintainer, and I'll explain what these are in a minute. I'm the deputy maintainer of AstroPy coordinates and AstroPy units. I'm the infrastructure lead for the tutorials, and Leah is now the content lead. I don't see Leah, but she's around somewhere. And I'm the maintainer of, is she behind the column? She is behind the column, good. I'm the maintainer of an affiliated package for doing galactic dynamics and stellar dynamics, which is called Gala. So how did I get involved with AstroPy? So I went back and looked at what my first contribution to AstroPy was, so to the core package, I should say. So it's back from 2012, which was around the time, one of the first meetings we had, I think, at Space Telescope. And this is my first contribution, my first pull request. There were 0 new lines of code added, and I just sort of rearranged 4 lines of code. And there was a discussion around it, and that took 4 commits for me to do. So the next sort of major contribution I made to AstroPy was this pull request, which I like to bring up because that's one of the most important objects that I use now in code, which is the first implementation of the quantity object, which came out of discussions with Eric Tallerud and Tom Robitaille at this first meeting. And then fast forward to today, where number 7 contributor, whatever. The point, I'm not humble bragging, the point is top contributors can start small. Your way in can be a tiny fix to the documentation or some rearrangement of code that you think helps clarify things for other users, and that can be your way into one of these big packages. It's a good way for you to start getting the hang of how the process works, how the code contribution works to these big projects, which can seem very overwhelming. When you look at the Astro Pi code now, it looks like there's so many different modules, there's so many different sub-packages. How could I ever get into that since there's so much context behind it? Start with a small contribution. Okay, so what is the core package? So now I want to spend some time on that first column, talking about what you get when you pip install Astro Pi. So the Astro Pi core package, this is just taken right out of the documentation, I think. So it provides key functionality and common tools that are needed for doing astronomy and astrophysics within Python. So examples of that, and those are not well-defined statements, key functionality and common tools, that's a subjective thing that people have to decide on. But some examples of things you can do within the core package: unit conversion, representation of units and conversion of units, manipulating times. Most of you are astronomers and know all the different horrific time formats that we like to use and whether it's barycentric or not. File input-output, so reading, again, most of us are astronomers, so we know all the horrific ASCII files that we like to dump on various websites and download catalogs of. So there's file input-output, so it's supposed to make it easier for you to read and write these different formats. And then coordinate transformations. There's a lot of other stuff in there. I just wanted to give a couple quick examples. In code, so for example, using the unit system with the coordinates, you can do things like convert from decimal degrees to a string representation that has hour, minutes, and seconds, or grab a coordinate automatically from Simbad using the name of the object that you're interested in, and then convert it to string representation. Another example, reading and writing tables. So this is something I just used in a paper, actually. I had a table that was full of numbers and periods and eccentricities for binary stars, and I wanted to put a section of that table in a paper, so I just wrote it out as a AAS Tech Deluxe table. So this is just very quick examples. Of course, there's a lot more. There are many sub-packages within the core package. So we talked about units, table, coordinates. There's also, again, support for time, working with converting time representations, modeling, so there's fitting models to data, something we talked about a bit yesterday, tools for doing cosmological calculations and data visualization, and then sort of a mishmash of statistical tools that are generally specific to doing astrophysics or astronomy. So I guess the point is summarized here. There's a lot of stuff in there. I'm not going to go through all of it because we can have a whole unconference session on going into details about what's in the Astro Pi core package. But that's just a quick overview. Any questions on that before we go on? Yeah. Can we get stickers? Yeah, I found myself, 11:30 p.m. making Doge memes, and I was questioning what I was doing with my life. But anyway, not that I was working on my talk at 11:30 last night. But so who develops the Astro Pi core package? So this is a massive collaborative effort. I am not Astro Pi. No individual is Astro Pi. There's about 240 contributors, and there are about 20 package leads and maintainers who are responsible for the upkeep and the maintenance of the package. So I grabbed a couple plots from the latest paper that we put out about the Astro Pi project, which I'll talk about in a little while. But this is just showing number of Git commits to the Astro Pi core repository versus number of committers. So there's a couple of nice things. One is Eric loves that everything follows a power law, so I drew a power law over this. So you can see there's many users who have few commits, and there's a few contributors who have a lot of commits within the repository. So this is probably Eric, Tom, and various other people. This is just an overview of total number of commits over the entire lifetime of the repository. We can also look at the stability, like how often are contributors entering and contributing code to the package. So this is looking at the number of people who commit to the core package per month from the start of the package to now. So interestingly, we sort of saturated around 20-something people. So every month we get contributions from about 20 or 25 people to the core package. This is a list of all of the maintainers and the deputy maintainers for all of the sub-packages. There's a lot more people on this list if you go to astropy.org/team, but I just wanted to highlight people who have roles within the core package. I think these are all the people who are here today, so you can raise your hand if you're on this list if you want to find more. Yeah, so these are all maintainers and deputies within the Astro Pi core package. And the roles, so what do we actually do? It's fairly simple. The main roles are to evaluate and merge new pull requests that are contributed by users, keep track of who is contributing to the sub-packages, and then keep an eye on what feature development needs to happen within a given sub-package and track the issues that are surrounding the different sub-packages. Because we're at the point where we have so many different sub-packages and modules, no one person can ever keep an eye on the entire package. There's different domain-specific things everywhere. So we have this team structure where different people are responsible for different sub-pieces of the code. So this is at the sub-package level. We also have, and I think this was alluded to yesterday, we also have a coordination committee, and I knew that picture of Eric would come in handy one day. So Eric and Kelly are both here, and then both Tom Aldcroft and Tom Robitaille are not here, but it's a 4-person coordination committee. And they're responsible for the overall coordination and management of the project as a whole. So not just the core package, but the whole project, which we'll talk a little bit more about in a minute. But they'll, for example, evaluate new affiliated packages that are being proposed to be accepted within the project. They can arbitrate disagreements within feature disputes in the core package. And this is a key one, which Kelly is standing in the back, but managing finances for the project. This is a new thing for us, but it's one of the responsibilities for the coordination committee. So that's sort of who. Then we could talk about how the core package has happened. How did we get a group of these 240 people together to contribute to a huge project? And it's really because of two things. One is the package is open source, and the other is that it's being openly developed. So all of the infrastructure around the package is basically being handled through the GitHub website, which I'll talk a little bit more about. But this is a screen cap of the Astro Pi license, just to emphasize the point that Astro Pi is open source. And all that means essentially is the source code of the code is available in the GitHub repository, which anybody can go to and see, so long as GitHub is alive. And that code is licensed, so it can be reused, it can be modified, and reincorporated into other open source projects. So this is the license that we use, which is a BSD 3-clause new or revised license, which I urge you to think about. I won't say anything more than that. Another key aspect to the Astro Pi core package is that we have an open development model. So open source is, as Kelly and I like to discuss, open source is not enough. We also have to rely on this open development model so that any discussion about new code or about bugs or features that are being added happens in the public. So this is a screen cap now of a pull request that Dan Foreman-Mackey, who you saw yesterday, just submitted to the main Astro Pi repository. So there's a huge discussion around this already. Well, huge, 21 comments back and forth. This is a fairly large contribution, so you can see it came already with 55 commits with it. But the key point is that anyone can jump into the discussion, like PyAstro18, for example, and add something or their thoughts about why this feature should be incorporated or suggestions for how to improve different aspects of the pull request.
Adrian?
Yeah.
Can I just mention something with that?
Sure.
If anyone is an expert on that functionality and would like to help review it, I'm very happy to have that as a hack day activity.
Yes. Steve just wanted to comment that if anyone is an expert in this particular pull request that I'm showing as an example, so transit periodograms, come talk to us. We could have that as a breakout or an unconference session reviewing this pull request, which is great, but it would be useful to have some domain experts. Brigitte just volunteered, I think. I'm serious, she did. I already volunteered. Okay. Another thing is that, so for intermediate or small changes to the code base, direct pull requests are fine, but we also use a model that was borrowed from Python itself for proposing larger enhancements or changes to the direction of the project. So this is now a screen cap from a different repository, which is called Astro Pi apes, where the ape stands for Astro Pi proposal for enhancement. So you can see this one is ape 9. So this is from Stuart. And so larger changes to the code have to go through this initial review period where you first lay out what you want to do, why you want to do it. That is reviewed before people hit the ground and start actually writing the code for the things, to make sure that we all agree that this is new functionality that we want to be incorporated into the core package. So those are the apes, yeah.
I propose an unconference session on that as well, if anybody wants to work on that.
We have only ever worked on this during PyAstro.
Right, actually, yeah, you
I
can.
put a commit on it like 2
Oh, no.
weeks ago.
So first, Stuart just said, if anyone wants to work on this as an unconference session, talk to Stuart. But yes, the next comment down here, which didn't make the screen, says something about PyAstro18. So this ape pull request is heavily tied to Python and astronomy. Cool. Right, so anyway, the point, I guess, here is that our workflow for proposing new features, for tracking bugs, for discussion, most of that exists on GitHub. And so this is just looking at the Astropy project page as a whole on GitHub. So this is the repository I was just showing you, Astropy apes, and the core package is just Astropy. So the code lives on GitHub, but we use other open source functionality to keep track of things like software testing and documentation. So here's an example of continuous integration, which means the Astropy core package has a set of tests that basically validate the code that can be run in different environments. So for example, different Python versions, 3.5, different NumPy versions, whether you're running on OS X or Linux. It looks like we're all Linux now. So these are all tests that we run automatically through this service, which is called Travis CI for continuous integration. And so you can go to the Travis site for any pull request or any commit that's been made to the main Astropy repository and see which of these tests have passed or failed. And that's one of the checks that happens. So if we scrolled all the way down, you would see basically a status indicator in any given pull request that says whether the Travis build tests ran or not, and whether they succeeded. Cool. So we used Travis CI to run our test suite. This is a continuous integration service. And then we use read the docs to build our documentation. So this is those are both standards now in the sense for open source projects. Okay, so that's roughly the infrastructure around the Astropy core package. I wanted to note quickly that we now have 2 papers out about the Astropy project. Well, the first one is really about the core package from back in 2013. And just recently, thanks to a lot of coordination by Steve Crawford, we now have a second paper out with a much longer list of authors who have contributed between 2013 and 2018. And these papers, this one is going to be in the Astrophysical Journal. The other one was in Astronomy and Astrophysics. This is really a way to hack the attribution system. Publishing a paper about Astropy is not a perfect thing. Like, you wouldn't naively think that that's the thing that you want to do, because the day after we publish this, a new contributor could add to the code, and then they're not on this paper and they're not getting credit. But we needed to do something, because there were a lot of people who were not getting credit for citations to this initial Astropy paper. And so the current plan is to have, until something changes at the journal level, to have incremental papers released that people can cite. I think ideally, something that's been discussed a lot by the journal editors, especially within AAS journals, ideally we would be able to have a an author list that changes over time, but that introduces a lot of other complications, so I understand why it hasn't happened immediately. So there's 2 papers out now, and that's, I think, a good segue into discussing what I mean by the Astropy community. So this is taken from the Astropy Code of Conduct. We have a Code of Conduct. You can click on that link when I put the slides up, and it'll take you directly to the Code of Conduct page. But I think this line from the Code of Conduct summarizes what it's all about, why we have a Code of Conduct. Our goal is to keep ours a positive, inclusive, successful, and growing community. And so that means abiding by a set of guidelines and rules when we interact with other people within our community to keep these statements to be true. So who is the Astropy, or what is the Astropy community? It's really us, as I mentioned before. It's the union of users and developers and scientists and package maintainers, et cetera. There's many entry points into the community. You're in one of those entry points. I think Python and astronomy, as you can see, there's a fairly large Astropy presence here, and so that's one of the ways you can get involved within the Astropy project and community. But other ways you can do it more remotely, you can join the mailing lists. So there's 2 mailing lists. One is called Astropy, the other is called Astropy Dev. And this is not quite right, but roughly it's like users and developers, those 2 lists. And they're fairly low traffic. Again, when I post this, you can click on that link and it'll take you to the page where you can sign up. There's also a Slack channel, Slack, what is the superset? Workspace, thank you. Which I'm sure if you talk to Stuart, he would be happy to get you set up with. We have a regular telecon schedule. So again, if you click on that link, roughly once a month, we have a telecon for all of the developers to get together and chat. That is not a telecon where you can join and ask us about how to make code work. That is a telecon where you can hear about what the new development efforts are and how you might be able to contribute to the project. And new is this Astropy event calendar. I don't know what the official name is, but something that Kelly is working on, a space to put all of the events associated with Astropy into one place so you can see when the different telecons and workshops and things like that are happening. There's also several conferences where you can learn about Astropy or become involved. So that there's usually at every AAS meeting, we have workshops that are run, mainly about learning Astropy, but there's also been sprints. So actually this summer, there'll be a sprint associated with the AAS for working and contributing to Astropy. There's this meeting. There's smaller contingencies who go to meetings like Astro Hack Week and other dot astronomy, who Sarah is deeply involved with. And then we also fairly infrequently, but importantly, have coordination meetings where we gather anyone who is a contributor who can make it to one of these meetings together in the same room to discuss the sort of health and long-term goals within the project. And again, these are all places where we're interacting with each other and contributors and users, and so we abide by the Astropy Code of Conduct. So that's the community. So now I want to switch to the last pillar, the 3rd pillar, which is the ecosystem surrounding the Astropy core package and project. And what I mean by ecosystem is that the core package provides the base functionality for many other packages to leverage. And those other packages, if they want to be acknowledged by Astropy or the Astropy project, then they're affiliated packages. Otherwise, they're just packages that depend on Astropy. So there's the core package, which again just provides these general tools, which is long-term stable, has a fairly long release schedule, so every six months or so. The affiliated packages are separate from the core package, and these contain typically more specialized tools. They can have a faster development and release cycle that's decoupled from the main Astropy core package. But they can also be Astropy coordinated packages. So there can be affiliated packages that are actually coordinated by the Astropy project itself, but they are distinct from the core package. You can see a list of them here. Here are just some examples. So there's many, this is actually a new terminology that should be released soon, but there are going to be several Astropy coordinated affiliated packages, and these are just 2 examples. One is FOTUtils, which is used for doing photometry of astronomical sources. The other is Astro Query, which has tools for querying astronomical databases and data sets remotely. Two examples of affiliated packages that are not coordinated by the Astropy project are PyAstro, which is developed by Juan, who's somewhere around here, and then AstroML, which is the package, astronomical machine learning data mining package around this book that was put out by Željko Ivičić and Andy Connolly and Jake Vanderplas a few years ago. There are many more in each of these categories. I just wanted to highlight two examples. Another example is Astroplan, which Brett has been heavily involved with. So the ecosystem around the Astropy core package is really designed to fill in all the gaps that the core package can't provide. And so the infrastructure that we have that many people in this room have worked hard on surrounding those packages is designed to make it easier for scientists to package and release their software and perhaps contribute it to one of these affiliated packages. So the main thing is this Astropy package template, which was mentioned yesterday, which just provides a bunch of template setup, installation, documentation infrastructure, testing infrastructure surrounding various words that I've said, like Travis, Pi.test for testing, and Sphinx for documentation. So you can check this link out if you're interested in starting a new package or making your package an affiliated package, or just want to have for free all of this infrastructure. It doesn't have to be affiliated if you use the package template. So that's sort of an overview of the Astropy project. One to then just switch to, for new users, just a quick sort of few-step list of how to actually use Astropy. It seems like there's a lot of stuff in there. How should I use it? Well, you can install the package, and then many other packages as well. Then you can look at the documentation for reference, for examples. If you find maybe there's a bug in the code or you think the documentation needs more examples, make a GitHub issue and open a discussion with the developers. Maybe you know how to fix that bug you found, or you know what examples would be useful to add to the documentation. Submit a pull request with those changes. Maybe you want to add very cool new things or features. Then it's probably best to talk to one of the key developers through Slack or the mailing lists before you submit your pull request, because they'll help you condense what you're going to do and make sure that it is still relevant for contributing to one of these packages. If you want to learn Astropy, there's a new initiative we're calling Learn Astropy that Kelly and Leah and I and many others are involved with, which has funding now from Space Telescope Science Institute for developing educational resources such as tutorials. So speak to Leah or me or Kelly. If you're interested in contributing to this, I think we could make this an unconference session easily, creating tutorial material for the Astropy tutorials. So I'll end with just a couple of things that I view as now challenges within the project and directions for the future. So one is, if we went all the way back to the beginning, you saw that there's fairly rapid growth of the project in terms of number of commits and contributors. We're now sort of in the plateau stabilization stage. So one question is, how do we get back onto the growth curve? And do we want to get back onto the growth curve, or do we want to just maintain and stabilize the package and various packages? If you remember back to that table of names that I listed, some of the names were blue and some of the names were unfilled, which is not a real person. So how do we prevent burnout from developers who are in these maintainer roles or deputy roles? How do we get new people involved into the roles that are currently unfilled? So what is the pipeline from user to contributor to maintainer, and how do we foster that pipeline? And then another more recent thing is that we've applied for serious funding from the NSF. And so if we got that funding and the project continues to grow with official funding, which is a new thing for the Astropy project, how do we preserve our current development culture, this very open and flexible and interactive online community? So I'll end with questions. Those are questions, but also your questions, and we can discuss this more later.
So actually, we are running a little bit over time. So if you
Not
have
by my clock, but that's fine.
okay, very quick questions, or as Adrian said, that questions are open during all coffee breaks and talk to either of us.
You showed the plot that tapers off of, what is that, commits per month?
Yeah.
Do you have the same plot, or do you know what it would look like for the number of first-time contributors over time?
I don't have that plot, but we should definitely make that. We could have an unconference session on making plots like that. Yeah.
It lives in Astro Pi procedures.
Yeah, it could use a better name.
Any other question? Okay, then let's
Cool.
thank Adrian again.